to a whole bunch of studies that I've worked on over the past 5 or 6 years, and they're all revolving around the premise of risk assessment and the three main components. And this equates to the likelihood of impact, likelihood of failure, and consequences of failure. And then towards the end, we're going to just touch on some future projects that I'm planning to work on or in the process of developing. So urban trees, like many of us know, provide a variety of benefits from environmental aspects to economic factors, societal functions, stuff like that. But then urban tree failures can also pose significant consequences to things like public health and safety, property damage, and then they can disrupt services or activities as well. But the one thing to keep in mind throughout the process is that the risk of injury or death as a result of tree failure is extremely low. In the US, it's somewhere around about 36 deaths per year. So it's really low. But when these events do happen, the news and media tend to blow them out of proportion, like the trees are falling out of the sky, when that's not the case in reality. So when you look at professionalism in arboriculture as it relates to a general sense, and then we'll go into the risk assessment side, but there's many available careers that meet or exceed the national average pay. And there's a wide array of industry credentials and professional standards. So there's this assumption that having industry credentials makes you more qualified than somebody without. So there was a study by Kozer and Smiley, and what they found was that certified arborists were 4 times as likely to recommend retaining and monitoring a tree when they were out there assessing the risk. And tree risk assessment qualified arborists, or track arborists, like you'll see throughout the presentation, they were 2 times more likely to do the same as compared to both certified arborists and those without their certification. So what they concluded was that the assessor performing the assessment likely has the greatest impact on the final determination of risk. So this will be important as we're going through this, that kind of influence that the individual has who's conducting the assessment. So risk assessment in general, it's a systematic use of information to identify hazards and then estimate the associated risks. So there's many different methods across a variety of disciplines, and it's typically the first step in the process of decision making and ultimately risk management. But keep in mind, it can be highly subjective. So failure to recognize or undervalue the benefits of trees can lead to vague, uncertain, and subjective recommendations. So, one person's idea of risk might be completely different from another person's. So more specific to tree risk assessment, most methods evaluate 3 components, and that's the likelihood of impact, the likelihood of failure, and the consequences of failure. So the likelihood of impact, this has to do with a tree or tree part impacting a target. Targets are people, property. And then the likelihood of failure, the next component, this has to do with things like weather conditions, defect severity, and then the likelihood of failure within a set time frame. Are you expecting the tree to fail within 1 year, or possibly, is it a 3-year time frame? And then lastly, consequences of failure. This is if the tree fails and hits a potential target. What's the likely outcome? Is somebody going to get injured? Are they going to die? Will it cause damage to property? So typically these factors are given ordinal ratings, and then they're summed or combined to yield an overall risk rating. And ultimately, the arborist is responsible for conveying accurate and timely information and stating the need for mitigating any sort of risk, whether it be from pruning or maybe whole tree removal, and then also assisting with the decisions based on the actual risk. But in the end, they're not making the decisions for the homeowner, they're just providing them with the information. So arborists use various levels of assessments to determine the potential risk associated with the tree. So there's 3 levels that are commonly used in most risk assessments, and that's a level 1, and that's going to be a walk-by or drive-by assessment, and you're looking at the tree from one vantage point. So you might just be driving down that road or walking down the sidewalk, but you essentially only see one side of the tree. Level 2 is the next level up, and that's a 360-degree inspection from the base of the tree. You're looking at the site conditions, and you might use a wide array of basic tools. And what I mean by that is a diameter tape, soil probe, maybe a clinometer, rubber mallet, binoculars, things like that, just to give you a little bit more information. And then a level 3, this is the use of advanced detection equipment such as sonic tomography maybe, or a resistograph. Maybe you're going to do an aerial inspection with a drone, or possibly do static pull tests to check the stability of the tree. So as the levels of assessment increase, so does the necessary training, the time, and the equipment needed to perform the evaluation. So currently we have several qualitative methods that are used and accepted throughout the industry, but there is no industry standard. In the US, the closest thing we have to that is the ISA Tree Risk Assessment Qualification, or TRAC. And then in the UK and Australia, they have a similar method, but it's kind of slightly different in its approach, but it essentially looks at the same components, and that's the Quantified Tree Risk Assessment Method, or QTRA. So somebody's got their music playing. If they could mute that, please. Thank you. So the other thing that kind of ties into all this is risk perception. So in general, it's a subjective assessment of the probability of an accident happening, and essentially how concerned we are with the consequences. So as I mentioned, this can vary from person to person. How you see risk could be completely different from how your neighbor sees risk. And when there's a tree in between you, it could lead to an interesting situation. But it's intimately tied to the decision-making process, and it has the potential to hinder rational decision-making, not only for members of the public, but it can also do that with professionals as well. So this can affect things like recommendations and then the subsequent outcomes of a situation. And as I mentioned before, the media has this ability to sway public perceptions as to the frequency and severity of a risk. So it can lead to unfortunate situations and kind of a perception among the public that trees are falling out of the sky. So an individual's perception of a risk can be equally as influential as the reality of a risk. So this can result in misguided mitigation measures. And with anything that has the potential to cause harm, there's the actual risk, the perceived risk, and then the assessed risk. And these might not line up sometimes. So some have argued that this guise of objectivity assumed by experts is a fallacy, but there's no way to eliminate the human perception from a risk assessment. We can't walk up to a tree and just scan it with some piece of equipment and it tell us when it's going to fail. So you still have to rely on that human component. So an individual's experience with risk can alter their perceptions, leading towards either safer behaviors or perpetuating riskier behaviors. So all of us have different tolerances for risk. Think of the person with the shark there or hanging on the edge of the cliff. You wouldn't catch me in either of those situations, but for some people, that's acceptable and sought after. But experts across disciplines are being held increasingly more accountable for their decisions regarding risk. So they tend to rely on codes and standards rather than performing risk assessments. And in tree care, this can be problematic because risk is weighed against benefits, and trees are complex structures that exist in dynamic environments. So you have variable weather conditions. Obviously in Florida, we have hurricanes where, up in the north, like center of the country, they don't have hurricanes. Obviously they have tornadoes, but you have different weather variables that you have to take into account. And then also the consideration towards occupancy, how much pedestrian or vehicular traffic is in and around the tree. So uniform decision criteria are unlikely to capture all scenarios experienced in practice. So with expertise comes a higher level of responsibility, and beyond an expert's assessment, there are many outside factors that can influence their recommendations and the ultimate decisions that are made on the tree. So when a tree-related accident occurs, risk aversion, fear, they can both influence the decision makers, and it can lead to things like unwarranted tree removals. So tree risk assessment methods, they're obviously imperfect and they can be influenced by an individual's bias or perception. But previous training and experience and accreditation, they might only go so far. So different arborists can potentially look at the same tree and have different assessments of risk. So perceptions can be difficult to overcome when working with a client as well. Both risk averse, risk tolerant perspectives can be equally problematic. And there can be this unwillingness to change someone's mind. Maybe they love that tree because their grandparent planted it and they moved in their grandparent's house. or that tree might be by their child's bedroom and they're, fearful that it might come down in a storm. So that can kind of shift how they view the actual or the perceived risk associated with the tree. So there's many unknowns regarding the perceptions of tree-related risks and the ultimate decisions that are made. So here's an example of a controversial case from Newcastle, Australia, and it looks at public safety versus the protection of heritage fig trees. So city officials were pitted against community activists, and there are a multitude of factors ranging from political to emotive, knowledge-based, values, media influence, expert opinion. All these different things kind of came together, and the various stakeholders ultimately affected how the individuals and the groups perceived the related risks. So several risk assessments were conducted on all the trees. And unfortunately, there were various levels of risk associated with the trees from the different assessments. Some people said retain the trees, some people said remove them. And ultimately, the city council decided to remove the trees. But the study concluded that the risk and how it was perceived ultimately equaled the manifestation of the time, the place, and understandings and beliefs of the individuals involved. So it might have had less to do with the actual risk associated with the tree and more to do with these peripheral factors. So eliminating some of the subjective inputs that might bring assessments closer in line with the reality of risk could potentially be challenging. So now we're going to dive into some of the projects that I've worked on over the years. And the first one, the objectives of the project were to determine if perceived occupancy rates correlate with actual occupancy rates, and then ultimately to assess the time of inspection and its influence on the perceived occupancy rate. So this has to do with the likelihood of impacting a target component that we talked about at first. So target occupancy, it's quantifiable, and it's typically the first thing considered. So if you have no target, you have no risk. Think of a tree out in an empty field, no targets, no people walking by, no cars driving by. If that were to fail, it doesn't matter. There's no risk associated with it. But if that same tree was, downtown in a major city, then the risk would potentially be high if there were some sort of reason to rate it for a high risk rating outside of the occupancy factor. And then the other thing is buildings and structures, they're always 100% occupancy. Can't really move those. So pedestrian and vehicular occupancy, it can be highly variable, depending on time of day, day of the week, where the tree is located in proximity to the occupancy. And then higher target occupancy ultimately equals greater risk. So as I said, trees in urban areas, they're typically surrounded by numerous targets. And the unfortunate thing here, or the thing that can kind of be challenging, is an arborist may only be on site for 20 or 30 minutes to do their assessment. So they might happen to catch it when the occupancy is, abnormally high or abnormally low for like an average rate of what that would be around that tree. So it might skew their perception and their ultimate assessment. And then most tree risk assessment methods consider target occupancy in relation to that likelihood of impact component. Yet few offer guidance on interpreting and applying actual traffic data to an assessment. So the study took commercial traffic counters and we used it to quantify pedestrian and vehicular occupancy. 4 sites were chosen to provide a range of occupancy levels. And then we assessed each site over the course of 2 weeks. And then at each site, we took pictures and video footage during randomly timed events. And this was both during peak and non-peak times. So this happened on the University of Florida's campus. So, in between classes, during classes, stuff like that to capture different levels of occupancy. So then we also used aerial imaging to determine the target zone of the tree. So if that tree were to fail, what's the furthest point it could reach? And potential area to reach if it would fail would be based on the actual tree measurements. So we measured everything out. This is where the tree would, potentially hit. Everything within that could be affected. And then target occupancy was calculated using things like average walking distance, the posted speed limits, the average stopping distance of both a person and a vehicle, and then how much time somebody would spend within the target zone. So the data was ultimately used to create video surveys. So we had 12 randomized video clips from the 4 sites during peak, non-peak hours, and then also seasonal variation. And then we had 4 randomized images that actually displayed the target occupancy that was averaged over a 24-hour period. So you see the tree up there on the top right. At that particular site, that tree had 7 hours of occupancy throughout the course of a 24-hour day. So we had 115 arborist participant, most of which had their certified arborist credential. And after viewing each of the videos and the photos, the participants used a 4-point Likert scale to rank target occupancy based off of each scene. So the occupancy based on visual indicators, some of the stuff we found here, the ratings did vary significantly given the time of day, but time of year didn't really influence target occupancy ratings. And then neither the presence nor the absence of the ISA certification or previous risk assessment experience was found to influence target ratings. And then we found at 3 of the 4 sites that the visual assessments of target occupancy did not match the actual occupancy. So ultimately, this can affect the outcome of the related tree risk assessment and maybe some of the recommended mitigation. So when you look at occupancy based on the still images against things like time of day and season, they were no longer applicable as far as how they affected it. And both actual occupancy and presence or absence of that ISA credential were significant predictors. So risk assessment experience was not significant predictor of target occupancy rating. And the second model ultimately explained a greater proportion of the variation than the first model. And again, that was based off of the still images with the actual occupancy rate put on the screen. So visual ratings for summer non-peak videos were similar to those given after seeing the actual traffic counts. And visual ratings for scenes filmed in the fall and spring during peak hours had the highest frequency of constant. So that's people rating it saying, you know, that's the highest occupancy rating, you can give it a 4 constant. So non-peak hours had the highest frequency of 2. So that's kind of that in between, you know, 2 and 3. Maybe you can't decide that it's extremely low or extremely high. So that 2 or 3 kind of falls into that range. And then across all 4 rating scenarios, the number of respondents who chose 3, which was fairly static, and then 2 occasional and 4 constant were much more variable. So there were little differences in the visual ratings by ISA certified arborists and non-certified arborist respondents. Both groups were more likely to rate the street scenes as either a 3 frequent and at least likely to rate the scenes as 1 rare. So the few ISA track arborists that were present in our sample were most likely to rate the scenes as 2 occasional. And the results indicate a possible relationship between ISA certification and more precise interpretations of actual occupancy rates. So overall, the results, when we look at impact on target rating consistency, the use of traffic counters decreased variability of the ratings, and non-certified arborists were slightly more variable in their ratings than certified arborists. So we asked some survey questions along with the video and still shots, and participants' perceived value of traffic counter data was the premise, and 64% believed that viewing the actual traffic counts changed their perception of target occupancy, that additional information. And then 70% believe that traffic monitoring systems are a worthwhile investment for arborists who regularly conduct risk assessments. And we concluded that traffic counters have the potential to quantify target occupancy and eliminate some of the subjective nature of assessments. And the ratings derived from the traffic counts were more strongly correlated with the actual measured occupancy than from the visual indicators. But ultimately, a clearer definition of qualitative variables could strengthen the rating systems. And again, most assessments, most people that do assessments and most of the methods do not call for the use of traffic counters. It would fall into that range of a level 3 based off of the current standards because you're doing an advanced level of assessment in a sense. So did a follow-up study to this, and the objective was to determine if traffic counts from a low-cost system will be similar to those derived by both hand counts and the commercial counters used from the previous study. So most tree risk assessment methods consider target occupancy in relation to that likelihood of impact component, like I'd mentioned. But other than the QTRA method used in the UK and Australia, and then another method that's coming up in the UK called VALID, few offer any guidance on interpreting and applying actual traffic data to the assessment. So Kozer and Smiley found that likelihood of impact is the most variable aspect of the assessment. And like I said, depending on when you visit a site, you might get completely different interpretations of what the occupancy is. So this lack of definition regarding site occupancy may reduce the reproducibility of risk assessments. And several studies have used traffic data and traffic counting devices to quantify the likelihood of impact component of tree risk assessment. Yet this data is not commonly used or collected in arboricultural practice. So in addition to this lack of familiarity with traffic counting systems, the cost of commercial systems may be seen as a barrier to practicing arborists. So to give you an example, the system we used from the previous study cost about $2,200 for a set of the counters. And we were able to create homemade counters for about $160 using parts off of Amazon. So the study looks at target occupancy and tries to identify solutions for assessing likelihood of impact. And we compared each system to assess their accuracy and consistency against the hand counters. And then the data was collected in 1 hour intervals during different times of day. So for vehicular traffic, it was measured in residential neighborhood in Gainesville, Florida. And this was in part due to this happening during the pandemic. So we had to scale back where we're actually able to go out into the field and collect data based off of restrictions by the university. But for the commercial system, the low field geomatic sensor was used. And then for the homemade system, we used an ultrasonic sensor. And the data was collected during different times of day to provide a range of occupancy levels. And we used noon, 2 o'clock, and 5 o'clock to kind of get variations there. And then prior to data collection, both devices were calibrated over various intervals. And then both devices were attached to an adjustable tripod to provide a direct comparison between the two. And the counters were set up to measure only the near lane of traffic. So, there was no false counting with potentially having 2 lanes. And the posted speed limit at the site was 30 miles per hour. So for pedestrian traffic, this was simulated in my backyard under self-isolation during COVID. And the commercial system used a thermal infrared microsensor, and the homemade system used a passive infrared sensor. And it was designed to provide a range of occupancy levels in 1, 2, and 5 minute intervals. So prior to data collection, both devices were calibrated over the intervals. And then they were also attached to a tripod and installed 5 feet away from the walking path. So when we look at the actual vehicle counts compared to the estimated counts, the commercial system had an average percent error of about 7%, and this was overcounting. And the homemade system had an average percent error of about 16.5%, and this was undercounting. So there's some variation between the two. And the noticeable variation across both the time sampled and the counters used, when we look at that, the average absolute percent error for the commercial system was lowest at around noon, and this was about 3.5%. And it was at its highest around 5 o'clock, so that kind of afternoon rush hour, and this was about 15%. When you look at the homemade counter, it was at its lowest at that 5 o'clock time at about 6%, and highest at about 39% around noon. So it was completely opposite with what the commercial system had for its lowest and highest. And the correlation between the actual counts and the commercial system was the strongest relationship that we found. So when you look at the actual pedestrian counts compared to the estimated counts, the commercial system had an average percent error of about 33%, and this was overcounting. and the homemade system had an average percent error of about 419%. And this is overcounting. And you're thinking to yourself, that's quite a bit. And we'll get into that here in a second, why that was. So during the morning sampling periods, the commercial counter had a percent error of about 13%, and the homemade system had an average percent error of about 1.3%. So during the afternoon sampling periods, the commercial system had the average percent error of about negative 42%. So is that undercounting? And the homemade system overcounted by about 941%. So what we found was as the temperature increased, the commercial system tended to underestimate and the homemade system severely overestimated. So there's some issues there with heat in the sensors. So the correlation that we found to be the strongest was the actual counts and the commercial system. So the effects of temperature during the pedestrian traffic sampling periods, the homemade and commercial systems appeared to malfunction in temperatures above 89 degrees Fahrenheit. And so we conducted additional replications under cooler conditions to test this theory, and it resulted in no false counts. So the heat definitely affected the sensors. And the homemade system was found to be more accurate and consistent during less extreme heat. And this speaks to the potential capabilities of the technology when not adversely affected by the heat. So if the QTRA method, the one from the UK and Australia, if we use their target ranges and apply them to the current study, the variability in accuracy has the potential to render different assessments of target occupancy. So if you look at the orange box there towards the right, the data collection that occurred during the afternoon hours when the temperature was at its highest, so above that 89 degrees Fahrenheit, the homemade counter, the false counts as a result of the high temperatures would ultimately render a higher range for target for 3 out of the 4 sampling periods. So the differences in accuracy between the counters tested has the potential then to affect the related management decisions. So this could be the difference between, pruning a defective portion of a tree or potentially its removal, depending if it gets bumped up to that higher risk rating because of a higher count of occupancy. So the results suggest that there's a high degree of variability among the devices tested, and the narrow range of traffic conditions assessed made it difficult to identify any relationships between the variables. So the devices need to be tested across a wider range of conditions. And the variability of the homemade counter could potentially be improved upon with modifications to the code. So as I said, we use parts from Amazon, but we also use an open source coding software to where you could go in and control the distance of the sensor, its sensitivity, and things like that. And then potentially using different sensors might improve the system or altering the design. We found that putting a cover over the sensor to block the sunlight coming in on the side improves some of the counts. So just different things we can do to try and improve the overall system. So it's currently unknown how precise estimates of target occupancy need to be in order to accurately assess likelihood of impact. And traffic counts are subject to subjective interpretations by the assessor. So risk assessment methods need to incorporate clearer guidelines related to occupancy and the risk associated with trees. And quantifying the likelihood of impact component could potentially lead to more accurate and consistent assessments. So now we're going to shift gears completely. And so we just looked at the likelihood of impact component, and now we're going to look at the likelihood of failure component from a case study that we had in Naples, Florida. And the objectives were to determine whether species affected by likelihood of failure during a hurricane and identify the most common damage types. And currently our understanding of likelihood of failure is the most limited of the 3 components. So likelihood of failure is influenced by intrinsic factors and extrinsic factors. And these include, for intrinsic factors, size, size of the tree, size of the part in question, any sort of structural defects. Is there some sort of bark inclusion, maybe decay at the base of the roots? And then things like for intrinsic or extrinsic factors, site conditions. Maybe you have a small planting space, poor soil quality, poor drainage, and then other things like pruning. So previous management, maybe the tree was pruned improperly, it was lion's tailed or overraised. These are all variables that can, increase a potential likelihood of failure of a tree. So trees fail when the load exceeds their load bearing capacity. And this happens during extreme wind events. So we're obviously familiar with hurricanes in the Midwest, that might be tornadoes. And then also things like snow and ice loads that they experience up north. So studies have assessed the impact of hurricanes on urban tree populations in various ways. They've quantified damage and debris, evaluated the likelihood of failure, and then presented species-specific wind resistance ratings. So most research is focused on tree plantations and naturally forest areas. And this can be problematic because the form of open grown trees differs from forest and plantation grown trees. So ultimately, it can be difficult to compare the results between the two. So several studies have examined wind-induced failure on urban trees, but few have developed failure profiles for tree species in hurricane-prone areas like Florida. So a lot of the work that has been done, it's either been further up the coast on the Atlantic side or in places like Texas and Louisiana, stuff like that. And again, a lot of it is, those natural areas rather than urban. And species failure profiles, they can be useful when modeling tree failures in catastrophic wind events. And they commonly involve an evaluation of structural and environmental factors leading to tree failure. So it's those intrinsic and extrinsic factors that I mentioned a couple slides back. So Hurricane Irma, which is the star of the case study here, reached the city of Naples, Florida as a Category 2 hurricane, and then slowed down to a Category 1 as it was going across the city. And it had an average sustained wind speed of about 76 miles per hour. So fortunate for us, prior to Irma, Naples had just completed an inventory of about 20,000 public trees. And the study focuses on a subset of that inventory, essentially the trees in the right-of-ways. So following the initial cleanup, the Urban Forest Strike Team conducted assessments of the trees. And the Urban Forest Strike Team is a Florida Forest Service rapid response team. And the team leaders, they have their ISA tree risk assessment qualification certification, and they conducted walk-by visual inspections of the trees from ground level. So that's that 360-degree, possibly using basic tools, at the base of the tree type inspection. And each tree was ultimately assigned a damage level and then recommended some sort of mitigation. And we looked at about 4,000 trees out of that 20,000. So each tree was assigned the damage levels and mitigation, like I said, and some examples of these damage levels. Some minor equated to minimal corrective pruning needed, and a whole tree equated to the tree was either severely damaged and needed to be removed, or the whole tree had failed during the storm. So in the table here, we looked at the species that were assessed by the Urban Forest Strike Team. And about 43% of all the trees were Swiatina mahogany. And then Swiatina mahogany, Ficus retusa, and Quercus virginiana made up about 71% of all the trees. And then Bullnesia arborea made up less than 1% of all the trees. And there was, all different makeups in between. So the figure here looks at the proportion of each damage type for each species. And the number on the left indicates the sample size, and the numbers on the right indicate the survivorship. So over 80% of all the trees survived Hurricane Irma, and about 74% suffered no damage, while about 15% suffered whole tree failure. So they lost a decent amount of their trees in the storm. And that was at, a Category 1 with those 76 mile an hour sustained wind speeds. So you can only imagine, as the wind speed increases, so could the damage. So the table here looks at the factors influencing tree damage, and we looked at things like species, DBH, and the presence of utility lines. And what we found was that for each centimeter increase in DBH, the odds of an individual moving to a lesser damage category increased by a factor of 1.01, which doesn't sound like a lot, but it was a increase to say the least. And then individuals near utility lines were 9 times more likely to be in a lower damage category. And what we equated that to was that trees near utility lines are being pruned on more of a regular basis, typically a 3 to 4 year cycle by the utility companies. So it's likely that more of the defects associated with those trees were pruned out over time and more regularly. And then we use Quercus virginiana as a comparison species because previous studies had found it to be very storm resistant. And what we found was that 6 species were significantly more likely to be in a higher damage category, where 2 species were significantly more likely to be in a lower damage category. So the figure here is a scatter plot of survivability, and 16 species and 8 hurricanes were looked at across Florida. And as survivorship decreased, survivorship decreased as the wind speed increased. So there's a proportional relationship there, as you would expect. And the survivorship of Quercus virginiana was high throughout a wide range of wind speeds. So we concluded that maintaining a resilient and diverse urban forest requires additional knowledge of species performance in storms. Like I said, there's been very few studies and even less that have repeat species other than Quercus virginiana. So we don't have a lot of data other than maybe some one-offs. And careful planning to provide shelter for less resilient species is needed. Sound arboricultural practices to reduce wind loads and minimize defects that can compromise structural integrity. And then an overall better understanding of the interactions between intrinsic and extrinsic factors that can influence wind-induced tree failures. And species failure profiles, they can help to guide arborists regarding planting and preparing for future storms. So the next study we're going to look at here shifts gears yet again, and we're looking at the consequences of failure component of tree risk assessment. And the objective here was to determine if visual assessments of tree limb size and part height are similar to actual measurements. So assessing consequences of failure is highly variable, and the assessor must determine the mass of the tree part and then its fall distance, and then also the resiliency of any identified targets. So diameter can be used to visually estimate the mass of tree parts. There's several green log weight charts out there that you can use that have scales for this, but not all tree risk assessment methods provide the user with diameter size classes to determine the consequences of failure. So the study assessed how arborists with different levels of experience and then training rated consequences of failure. And for this study, we had 106 participants. 70% had their ISA certified arborist credential, and then about 60% had previous experience conducting tree risk assessment. So each tree was assessed using that basic level 2 assessment, so that 360 degree from ground level. So participants assessed the trees from ground level, and they used a modified ISA basic tree risk assessment method to estimate the size of the tree part and the fall distance. So these were included onto the normal assessment method to give us a little bit more understanding of the consequences of failure component. So for the analysis, we modeled the effects of several variables to determine their predictive capabilities as they relate to the arborist's ability to accurately estimate branch size and fall distance. So the figure here compares diameter estimates for the base group, which were individuals that did not have previous experience conducting risk assessment or credentials, to the ISA certified arborist, and then those people who did have previous experience with risk assessment. And this was in comparison to actual diameter estimates. So what we found was that the base tended to overestimate by about 27%, and certified arborist overestimated by about 5%, and people with previous risk assessment experience overestimated by about 7.5%. So we found that the participants with tree risk assessment experience and those with their certified arborist credential were ultimately more accurate at estimating branch diameter, which you would expect. And across all species and professional levels, branch diameter estimates were overestimated by an average of about 5%. So they were pretty in line with the reality of the situation. So the figure here compares branch height estimates for that base group, the experienced group, and then this time ISA track arborist, and then in comparison to the actual height. So for track arborist, they underestimated about 4% of the time, or by about 4%. And the base level group overestimated by about 7%. And those individuals with previous risk assessment experience overestimated by about 14%. But overall, all three groups of arborists, they had estimates of branch height that were close to the actual measurements. So again, not anything too far out of line. So what we found was that previous training and experience positively influenced some of the variability related to determining consequences of failure. And then along with this, we also asked some survey questions. And what we found was that 70% of the participants believe the current definitions of consequences of failure ratings are clear and easy to follow. And then about 67% of participants feel confident in their ability to predict injury, damage, and disruption levels in order to predict the consequences of failure. So that ultimately goes back to, you know, can they visualize the height, the size, the resiliency components. So we concluded that the results showed some statistically significant differences for diameter and fall distance estimations between the arborist groups with different levels of experience. And the average variations were generally small and not likely to have a major impact on the overall risk rating. So that's good. And more research is needed to understand the potential damage produced from different tree part sizes and target combinations to help produce meaningful threshold guidelines. So we did another study in relation to consequences of failure, kind of a follow-up to this previous one. And the objective was to determine the accuracy of visual assessments of tree part size and then evaluate their effects on consequences of failure ratings. So the study surveyed 87 participants with varying levels of experience and credentials, much like the previous study. And 64% had their ISA certified arborist credential, and then 64% also had previous risk assessment experience. And for the survey, we assessed consequences of failure to determine the diameter of tree part in inches. So to do this, we had 20 different cross sections printed out to scale, ranging from 4 inches up to 39 inches. And they were accompanied by aerial and street view images of 1 of 4 urban trees. And this was all posted to a wall, and people walked by and assessed them. And then the target of concern was displayed visually as text, so pedestrian, vehicle. And then target heights were also provided for participants. So the participants estimated the actual part size and rated part size in 1 of 4 diameter classes. And the target and aerial images and street view images, they were used to determine the consequences of failure. And this was based on the ISA Tree Risk Assessment BMP rating scale. So for the analysis, we modeled the effects of several variables in relation to an arborist's ability to accurately estimate branch diameter and then also determine consequences of failure. So the figure here compares branch diameter estimates for ISA board certified master arborist and then that base group to the actual diameter. And what we found was that for all cross section images and professional levels, branch diameter estimates were underestimated by about 4%, so not bad. And estimates for the board certified master arborist were about 2 inches less on average than the base level. And base level arborists had estimates that were closer to the actual diameter compared to the board certified master arborist. So kind of counterintuitive what you would think there. The less experienced and less credentialed group were actually more accurate. So the table here compares estimated diameter classes and actual diameter class. So overall, the arborists were accurate about 75% of the time when they determined branch size based in one of those 4 size ranges. And the arborists were most accurate at estimating branch size for the smallest range. So this would be 1 to 4 inches. That was about 79%. And then the largest range, which is greater than 18 inches, and this was about 80%. So if you think of it, it's easier to visualize things that are really small and things that are really large, but it can be difficult to kind of get those, ranges in between. So something between 4 and 18 inches might be more difficult than those, extremes on either end. And then the arborist had the lowest level of accuracy when they assessed the branches in the third size range. And this was 10 inches to 18 inches, and it was about 61%. So in the table here, we're looking at factors that influence consequences of failure ratings. So the ISA board certified master arborist, parents, non-homeowners, they were more likely to rate consequences of failure as more severe than the base. And then board certified master arborists were 3 times more likely to have a higher rating. So in relation to targets and surroundings, participants' assessments of consequences of failure increased as the branch size increased, which is what you would expect. So the figure here looks at consequences of failure ratings based on actual stem diameter for both pedestrian and vehicular targets. So when we look at pedestrian targets, once the diameter reached about 11.5 inches, the consequences of failure ratings reached significant to severe and held to that. And then for the vehicular targets, once the diameter reached about 27 inches, the ratings reached significant to severe and held to that. So the differences here are likely related to perceived resiliency, cars being more resilient than human body, and value. We should, and hopefully this is the reason why, but value life more than a inanimate object like a vehicle. So we found that previous training and experience positively influenced some of the variability related to consequences of failure ratings. And the baseline was as or more accurate than the arborists with training and experience in estimating part size and height. And about 61% of the participants feel that the current tree risk assessment methods would benefit from the addition of a diameter-based rating scale. And we concluded that the variability is likely due to professional interpretation and an arborist's ability to accurately estimate part size and height above a target ultimately can affect how they view the resulting consequences. And our respondent rating data serve as an initial attempt at offering guidelines for size-based consequences of failure ratings. So some key takeaways from the research that we looked at of mine. It's possible to quantify the likelihood of impact and consequences of failure components of tree risk assessment. And this might reduce some of the subjective nature of assessments. And a better understanding of species survivability and the development of species failure profiles can aid arborists in hurricane-prone areas. So this is super relevant to us in Florida. And you balance species resiliency, species diversity, maximize tree benefits, and minimize the risks in doing so. And there's still many unknowns regarding the impact of professional accreditation on tree risk assessment ratings. So future research on the components of tree risk assessment has the potential to provide arborists with methods that are less susceptible to variability and based on the reality of tree risk rather than some of these perceptions that we've talked about. So now we're briefly going to look at some future research and beyond tree risk assessment and risk perception, future research needs to address potential design options to make our urban forests more sustainable. And we're going to look at why this is important. So throughout Florida, there's a high concentration of urban developments along coastal areas, and it's a mix of planned landscapes and preserved natural ecosystems. And trees are susceptible to intense wind events and periodically sustained damage. So even trees that appear structurally sound can fail if the wind event is intense enough. So trees often grow poorly in urban areas unless the infrastructure has been specially designed to accommodate tree root growth. And past research has found that urban trees have a high mortality rate. And this is due to things like poor soil quality, small planting spaces, drought-like conditions. They're subjected to construction damage and sometimes a lack of maintenance. So urban trees have this shortened life expectancy in comparison to trees found in natural areas. But certain trees do grow well in these tough urban sites, so they get planted heavily, but we need to be cautious and avoid things like monocultures. And unfortunately, less commonly used species may be difficult to find sometimes at nurseries, especially depending on the size and quantity that you need for your planting program. So the Intergovernmental Panel on Climate Change predicts that by the end of the 21st century, temperature increases will likely exceed about 2.7 degrees Fahrenheit. And there'll be an increased frequency and intensity of natural disasters, things like droughts, fires, extreme wind events, and pest outbreaks. And such events pose potential risks to our urban forest canopy cover. And here in the Southeast, we're going to experience warmer minimum temperatures and less precipitation. So research has suggested that climate change will make urban trees increasingly more vulnerable to those pest and disease outbreaks, but then also late spring frost damage and drought stress. So recent research has begun to evaluate prospective species from climates that are in line with those projected for the future. So essentially testing those species to their limits. And past research has suggested to plant the right tree in the right place, which I'm sure we've all heard before. But essentially, this saves time, it saves money, and you want to determine what grows well in your area. You can lean on local knowledge, literature, online resources, and then evaluate the site and planting space and determine the desired species traits and ability to survive at the site. So the goal is to maximize the benefits and lower the associated risks with urban trees. And Kozer found that survival rates, when they're low, ultimately equals a loss of long-term benefits. And successful planting ultimately begins with high-quality nursery stock that's free of major defects. So now we're going to look at some of my future research projects. So my interests overall have to do with hurricanes and tree survivability, risk perception, decision making, public health and safety, but then also arboricultural education, training, professionalism, species propagation and climate change, and then ways to find creative design solutions for sustainable urban tree plantings. So one of the studies I'm currently working on related to risk assessment is comparing commonly used tree risk assessment methods. So I'd mentioned the TRAC and the QTRA method. We're comparing those. There's three groups that we're using in our study: ISA certified arborists with no risk assessment certification, and then those that have their TRAC and those that have their QTRA. And there's 150 people from each group, and they assessed 3 trees using video surveys. And then they were asked questions aimed at gauging their tolerance for risk. And then ultimately we compare system ratings, consistency, and mitigation measures for each method and determine if the training affected the assessor's average risk rating. So that one's in the process of getting written up now. We just did the data collection. So hopefully I'll have some information on that in a future presentation. Another study that I'm working on has to do with sprout attachment and likelihood of failure. So we topped 318 trees from a couple different species: oaks, elms, maples, and magnolias. And the premise was based on utility pruning. So cuts were made on branches that were greater than 1.5 inches in diameter. And we left stubs of 18 to 24 inches that will eventually split and evaluate the spread of decay on. And then we're randomly going to select sprouts and pull them to failure every year for 4 years, and then evaluate the strength of attachment and the differences between the sprouts on trunk and the callus wood. I have a master student starting here in August, and their project is going to look at drive-by assessments, so that level 1 assessment in comparison to basic or level 2 assessments. And 3 trees are going to be used across 2 different seasons. So we're going to assess the same trees while the leaves are on and while the leaves are off. And we're going to evaluate assessments from arborists with different levels of training, experience, and industry credentials. And for the track arborists, we're going to compare the first time testing versus those that have recertified to see if there's any differences. And then we're going to compare the accuracy of each assessment level and determine if the additional information gained from that level 2 assessment compared to the level 1 has any effect on risk ratings and the recommended mitigation. So I want to thank everybody for your time. I know I ran it right to the wire here, but I appreciate everybody listening in. And if you have any questions, I'd love to answer them. So.
Hey, Ryan, we got some questions here in the chat already. Let's see. What's the minimum space for a canopy tree?
Minimum like planting space, or?
I don't know. I can kind of see a couple things there. You there, Dina? We'll see. We can come back to that one potentially.
I was going to say just, in a general sense, minimum planting space. If you're talking spacing between trees, it's going to depend on the species, what their size is.
No. No, what I was thinking about is within the urban areas, most cities, in fact, all cities have the parkway, the area between the sidewalk and the curb.
Yeah.
Okay.
Right away.
Generally, it's called parkway where you can't park. Okay. What is the minimum? And then, of course, you have mediums and within a street, you have medians and parking lots. So what is the current thought for the minimum width?
Like soil space that a tree can be planted in? The width of the soil? The width of the planting strip or the soil space?
Yes.
Okay, yeah. So as far as a school of thought, bigger is better, but a lot of times municipalities are constrained by, limited space just due to infrastructure, streets, curbing, sidewalks, stuff like that. Kozer and Hilbert came out with a study based off of minimum planting space a couple years ago. And one of the takeaways from it was, so you have the trunk flare diameter, which has to do with the zone of rapid taper. And that essentially goes 4 feet past the trunk flare. And then you essentially want at least 4 feet on each side of that. But depending on the species, so if you look at something like live oak, if I'm remembering correctly, up to 69 inches in diameter, you need at least 16 feet width of a planting strip for live oak. I think laurel oak was 54 inches and you needed 14 feet. And then if you look at smaller species like crepe myrtle, if you had an 8-inch diameter crepe myrtle, I believe you needed at least 3 foot width planting space. So we're not seeing that a lot of times in these urban areas. And, they're trying to maximize their canopy cover by planting in spaces that they have available. But, sometimes the species isn't necessarily fitting the space, once it reaches maturity. So it kind of goes back to planting the right tree in the right place. But, sometimes that can be challenging. But that's kind of where we're at as far as that goes. There are some, recommendations, but most cities don't necessarily have anything on paper.
All right, we got another one here related to fire, which is maybe a different type of risk. Is there a list of trees that are more suitable for growing in urban forests as it relates to fire hazards?
I'm not familiar with that list. I was actually just talking to a colleague the other day about possibly doing maybe some sort of rapid assessment for trees that have been damaged by fire in relation to, what's going on out in the West right now. To my knowledge, there's not any sort of recommendations on that other than the stuff that has been documented and the research that's been done related to traditional forestry, natural areas, stuff like that, that are prone to some of these wildfires. But as it relates to urban settings, not to my knowledge, but you can probably take some of those species that are in those natural areas and translate that over to if they're planted in an urban setting. But yeah, there's kind of a lack of information right now as far as it relates to fire in urban trees.
Going back here to the scientific and common names that you of the 3 or 4 tree species that have the highest and lowest overall failure risk ratings for Florida. I guess some of the master gardeners here want a little lesson in Latin. So so I don't know if you can pull that up here real quick, or if you know it offhand.
I know the Squietina mahogany is your mahogany tree. And I'm going to show my ignorance here. I don't remember what Bolnesia arborea is off the top of my head. I'm saying the Latin name so much I don't even.
Oh yeah, that one. It's Verawood, I think, is what they call that.
That might be it. And then Quercus virginiana is your live oak, and your Ficus rectusa is a ficus tree.
Yeah, there's so many ficuses. So
yeah,
so little time. But
no, I believe you are correct with the Verawood, because that was one of the ones in there. And I just looked at this the other day, but yeah, my Latin needs a little bit of brushing up on.
Yeah, well, no, I hear you. I mean, I have a lot more time to go stroll out and do the tree walks these days, like as an extension agent, like so. But yeah, and then I'm down here in the central South Florida area. I think that's like more of a tropical one. But yeah, let's see if we got anything else. High school Latin was way too long ago, says Max. So well, I mean, I don't know. I'm always curious here to hear more about risk, and I know you're trying to do more in that territory. What about like remote sensing and risk? Is there, I mean, did they just got to go off of like basically like health, remote, like basically like you can kind of look at like how well a tree is photosynthesizing and that type of thing, or
yeah, there's some health variables you can look at. Like I kind of joked about throughout the presentations, it's not like we can just walk up to the tree and scan it and be like, okay, the tree's going to fall October 16th, 2048. There are a lot of, environmental factors and cultural factors, the management of trees, things like that, factor in to, whether the tree could potentially fail. And then obviously it's confounded when you're in places like Florida with hurricanes. So not only is it the wind speed, but then precipitation, soil saturation. So it's kind of this like collection of variables that kind of come together and get you to this breaking point. Some can be more influential on the likelihood of a tree failing than others. And trees, they're pretty resilient. They can withstand a lot. But yeah, I mean, I think we're pretty far off from, even as advanced as remote sensing technologies are, I don't think we're close enough to seeing, something that could determine one way or the other this tree is going to fail. Maybe you could look at some sort of, root breakage underneath the soil that's not visible, or some root defects or damage that might change your perspective of a risk rating and make you lean one way or the other. But nothing definitive, at least in our current state of things.
Yeah. Well, yeah, I know. It's even like the drive-by stuff. You can only got one side of the tree. I mean, it's just.
Yeah. And the major defect might be on the opposite side of the tree. And, that tree might look perfectly sound on the side you're looking at. So, and, depending on when you visit, like I was talking earlier about different seasons, especially up in the Midwest or more temperate climates, when you have leaf drop, you might see a large, bark inclusion, codominant situation up in the crown, in the winter, that you might not see in the middle of summer when the tree's, fully leafed out, especially if it's a healthy tree. So yeah, different things like that. But it's still a work in progress. In general, there's a lot of subjectivity to risk assessment. And ultimately, it depends on the individual doing it. And you hope they don't have any sort of, preconceived biases. And then that gets passed on to the homeowner. If the homeowner has those biases, and then that can kind of reflect on, how the process goes. And then there's, the ordinances and codes for the city, and whether or not, they're strict or enforced. And yeah, there's just a lot of components related to whether or not a tree actually, happens to have one type of mitigation versus another.
Yeah. Well, as long as they take care of those laurel oaks, I guess. Well, anyway, I guess if there's no more questions here, I think we'll let Ryan go. He's got lots of writing to do, applying for many grants and wrapping up many papers, I'm sure.
Always the writing. Yeah.
So
I appreciate everybody joining in today, and I always look forward to opportunities like this to share my research. So hopefully I'll get to speak to you guys again at some point in the future and have some new stuff to show you. So
yeah, thank you for making time for us. And I mean, that was I feel like that was a really good dive into the world of risk. I mean, and I'm sure I'll be unpacking this one here for a while here, but I think that you gave them a really good perspective today on what the cutting edge is in terms of like how we think about trees and management, like on an individual level here. So yeah, thank you, Ryan.
Yeah, and if anybody has any questions that they think of a couple of days from now, tomorrow, whatever, just shoot me an email. John should have my email information. Otherwise, it's publicly available. Just search my name, UF, on Google, and it'll be there. So, but thanks again, and have a good rest of your week, everybody.
Take care, Ryan. All right, folks, we're at that point in time again here for Lunch and Learn, all members meeting. And so I'm going to go ahead and just kick it off here with our usuals, try and see where we're standing right now in terms of, I guess, just where we're our standard monthly things that we try and go over here. So I think normally legacy is Jody here. No, Jody. Okay, how about Head Start, Brenda? Okay. Well, I think I'll just jump into it here. We went a little long. It was kind of a long lunch and learn, so I'm guessing some people probably had to head out. Next lunch and learn will be here in person for the month of August. I got to try and meet up with Carmen and figure out a plan, but I think that the schedule is not going to be typical for an in-person one. I think we're going to have eating here throughout the first hour, and like from 12 to 1, and then I think we'll have a little bit of a meeting, probably in the conference room, or not the conference room, the auditorium, and we'll just meet up there and we'll talk about where the program is in more depth, what we can do in person, what we need to be doing at this point in time, as we're kind of in many aspects of the program, we're taking out of mothballs right now as new opportunities open up to us. So I just wanted to, next week or next month, pardon me, like to be a major, lunch and learn will be a lot of actually just catching up and like talking about standard operating procedures here. Maybe I'll have a quick lesson in there too. Just something simple that we can do after we get done with the big meeting. But I think that is going to be the bulk of the lunch and learn, is going to be us just catching up here. So with that said,
John, can I say something, John?
Yes,
This
Dina.
is Dina. Okay. The first hour, everyone, is going to be social. And the advisory committee's meeting, I think this week, whatever, and we're going to kind of structure it just a teeny bit, but that first hour is social, and there'll probably be food involved. No doubt there'll be food involved, but I just wanted to share that with you. So we get to see each other.
That's the plan. I mean, it's not 100% set in stone. I got to make sure that like our food people, that'll work for them. like but I would definitely like for that to be the situation. And then like also I think there's probably going to be a lot of people, more than we might predict or what might come typically. I think we typically have that room set at a capacity of 55. So I think we're going to see about having, like, if you guys want to eat and spread out, like that, there's more places that you can go out, all over the campus here. So anyway, yeah, virtual hot dogs. Sorry, Max, there'll be real hot dogs now. So, will there be lunch, or should we bring our own food? Yeah, there'll be lunch. So we've got everything set up to be able to do that again. I've been getting any other questions? I've got one major thing I want to show you all here. And it's regarding Better Impact. Because I've been getting a lot of questions on how to sign up for things on Better Impact. So I'm just going to share my screen and show you how to do that real quick. Okay. So I go in, I'm logging in on my admin login, but I need to show you all. I can also get over to see what you all see. So here's the big thing. A lot of people have been saying they've been trying to log their hours for stuff and that they can't find what they need to log into. Here, I'm going to give you an example. If you haven't signed up in the opportunity section, you're not going to be able to find the particular activities that you need to be logging hours for. So if you just go to your opportunity list, and anything that you're volunteering for or that you want to volunteer for, you need to be able to go over to the activity, click it, select it, and then you can sign up for it. For a lot of them that have shifts going. But for some of these things, you're going to have to, for example, sign up for it. If the scheduling isn't on a set schedule and the time slots just aren't in the calendar, it's something that you log yourself, you have to sign up for it first. So this is true for continuing education as well. That's the most important thing. But then if you afterwards, once you press this sign up button, so let's just hypothetically say I want to sign up to do the Writers Bureau. I'd go to hours, select activity, and I would just select Writers Bureau. And then I can just pick a date and time and number of hours that I did it. You just save and log it. But everything, and everything should be on here at this point. If there isn't, if there's something that you think is missing, let me know. And generally, also, if you're in doubt and it's something that you're doing that's pretty general or vague, there's always the office assistant that's available. That's a pretty big catch-all for just general things that we do here. So you can just click General Office Assistance, and you can sign up for that one as well, and then plug your hours in through that. So that's it. I just wanted to share that as well. Will classes mostly be in person now, or needing assistance, or are they remaining mostly virtual for now? We're going to start percolating over towards doing the classes in person again. I've got another one in August. It's going to be virtual with Tia. And then I think that I'm going to try and have them all in person at that point. But we'll see. None of us have really been trying that hard to do it because we're kind of just in Zoom mode. It's what's working. And they're also supposed to be setting up the Magnolia classroom, the big one at the end, to be able to do virtual plus in person at the same time. So we're looking forward to that. I mean, there's no rules here against doing in-person classes. It's just we haven't been doing it lately. Yeah, Zoom and virtual hot dogs are so 2020. I know. So we're getting to 2021 here, Max. So all right, folks. Well, there's going to be a lot more to catch up on next time. And good riddance to 2020. I'm seeing the chats here. We're really going to be in the 2021 next time in person. So I'm looking forward to seeing you all there. This concludes.
John?
Hey,
John,
Fran?
Fran, I have a question. For anyone who signed up for Adopt a Tree, who's
Yes.
never done it before, are we going to be contacted by someone as to, I know it's in Christmas, for Christmas, but other
Yeah,
than,
for anybody that's going to be doing Adopt a Tree, the standard protocol for that is just bring yourself, be there typically an hour before, and we'll just meet up and we'll take care of business from there. So the
Don,
event. What's up, Penny?
I have a question. So I'm assuming that all those people who have not been vaccinated will be wearing masks inside.
I mean, inside when we have our meeting, is that what you're asking?
Yes.
Um,
They should be, that this is the recommendation.
well, it's the recommendation, but there's completely no way to enforce it. So, I mean, if you want to go and like start asking everybody, Penny, and on your own, that's okay. But we can't do anything in terms of that regard here.
So we
Like,
just have to take people's word that they were inconsiderate enough not to get their vaccine.
all right, Penny. Like, well,
Sorry.
I understand what you're saying, and
This is a pretty important point, because now that we're getting together, there are people who are still not. And
I'm trying to give everybody space too, like by using the auditorium. So,
say thank you, Max.
so yeah, Adopt a Tree. Just try and be there an hour early or so. I'll be there at 7:00 for Christmas, and I will send you all an email leading up to Saturday morning as well, sometime on Friday. So,
excellent. Thank you.
so, all
How
right.
do we do our hour? How do we do our hours today? Our time today?
Let's just go with 1 hour for continuing education and 15 minutes for the all members meeting. So the all members meeting is also an option for what I just showed you. So I think that works. Thank you for sticking around, folks. That was a long one. It was pretty intense in terms of the quantitative perspective, like compared to normally what we do. But I hope it made sense. If not, come talk to me and I'll try and give you some perspective on it. I love to talk about trees. So, all right, folks, will you take care? Stay snarky, Max, and I'll see you all and here and there in a month. Take care, everybody.